Let's do some more review for the EOCT. This is using the diagnostic test, problems 14 through 17, and this is at the top of page 4. Alright, we're going to start with problem 14. We want to find the sine of C, the cosine of C, and the tan of C. So let's do a quick review about trig before we start. Remember, the ratio of sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan, my legs are tan. Opposite over adjacent. Alright, now, you notice I want the sine of C, I want the cosine of C, and I want the tan of C. First thing I like to do is I like to slash my angle. The reason I do that is because I slash the hypotenuse, which is always the longest side, and I also slash the adjacent. That leaves me the opposite over there that has not been slashed. This can help you a lot of times keep all those different sides straight. Alright, let's look at the sine of C. That's opposite over the hypotenuse. Well, that's going to be 9 over 15. Yeah. Now that's going to be, we need to reduce that. Use your calculator, your ABC button. If you don't know how to do that, ask somebody, or do like what I do. What goes into 9 and 15? 3. That reduces down to 3 over 5. Now let's do cosine. Cosine is the adjacent over the hypotenuse. Those are the two sides I've slashed. So it's going to be 12 over 15. Again, reduce. Both of them are divisible by 3, and I get 4 over 5. Finally, I got my tan, and my tan are my legs. Alright, so I look for my legs, and that's going to be 9 over 12. Again, 9 and 12 are reducible by 3, and I got 3 over 4. Okay, hope that helped you. Stop and do problem number 14 on your worksheet. Alright, on this one we've got the knight sits on top of a horse, putting his head 8 feet above the ground. He uses his helmet to determine the angle of elevation to the beautiful princess, and it is going to be 15 degrees. And he knows that he is 500 feet from the castle. How tall is the tower of the castle? Alright, now let's look at our problem. We got a nice little diagram here. And the first thing I'm going to do is I'm going to get out my sword and I'm going to slash the angle. When I slash the angle, I got the hypotenuse and I have the adjacent. What didn't I slash? The opposite. Alright. Now I want to know how tall that castle is, and as I'm looking at my picture, that looks like it's going to be the opposite. And I know the adjacent is 500 feet. Ooh, I got my legs going here, and so I'm going to be using tan. Okay, now let's see what we know. We do know that my angle is 15 degrees, don't we? We do know the adjacent is 500. And oops, we don't know the opposite. No, that's sort of what we're looking for, isn't it? Alright, but if you look at the diagram, it's really not the height of the tower. The height of the tower is x plus 8, because remember the knight is sitting on top of that horse and he is 8 feet above the ground. Alright, so let's go in and solve for x. Okay, the tan of 15 equals x over 500. That's the opposite over the adjacent. This I can easily put into my calculator, but first I've got to cross multiply. So it's going to be 500 times the tan of 15 degrees, and that's simply going to give me x equals 133.9745, and that's only x. That's only part of the height of the tower. Remember, we're looking for the height of the tower, and before we said x plus 8 because the knight is on top of that horse. Okay, so what are we going to do? We're going to add 133.97 to 8, and it looks like the tower is 141.97. Now remember, this would round up to 142 feet. Okay? All right. This problem is kind of interesting. It's kind of a thought problem, but I'm going to go over a couple different things. Finding the measure of the angle given the sides. Now before we were given the angle was like 15 on the last one. This time we know the sides and we got to find the angle. Now I'm still going to come in and slash. I still know I have a hypotenuse and the adjacent. Look, it's 400. And then the opposite is going to be 300. I got my legs again, don't I? And my legs are tan. So I come in here and I'm going to say the tan of theta equals opposite over adjacent. Well, do I know what theta is? No. But do I know the adjacent? Yes, 400. Do I know the opposite? Yes, 300. Can I plug that in? Yes, I can. But notice I don't know what my angle is. What do? We use the inverse, don't we? Okay, remember how to find that on your calculator? Most of your calculators, Texas Instrument, you do, if you want the inverse of tan, you go shift, right, and just hit tan. All right, so we come in, and if you do that, this is what pops up. What are you going to plug in? Well, this is what we plug in. 300 over 400. The opposite over the adjacent. Push enter. We now know that theta is 36.87 degrees. Okay? Now, to go to the question that really is problem 16, I want you to think about something. If I know the tan of some angle H is 1, what does that tell me about my triangle? Well, first of all, tan is the opposite over the adjacent, right? So what it is saying is that the opposite and the adjacent is 1. What kind of triangle do you have to have if your two legs are equal to each other? Think about it. Okay? And do problem number 16. Yes, Jack, Black, and Elmo say stop now and do problem number 16. Okay, we're given triangle CAT. What is the relationship of the sine of C and of the cosine of T? Now you notice I already came in here and told you what the sine of C was, what the cosine of C was, the sine of T, the sine of the cosine of T. Look at them. Look at them closely. Notice that C and T are what kind of angles? They're the acute angles of your right triangle, aren't they? Remember, they are complementary angles. They will add up to 90. Let's come over here and look again at this. The sine, cosine, and tangent. I'm going to say this with the arrow. I'm going to say that with the arrow. Do you see a relationship, people? I hope you do. Stop! Oops. Do problem 17 on your worksheet. That does it for this video. Bye, guys.